Hello again, simulation team. This is going to be the big video. This is where we will take the Rocket CAD and set up a simulation with it. Now, the file itself is on our Slack page, the CAD file for our geometry. So make sure you download it and put it on your desktop before we proceed. First thing we'll do is go into Geometry, launch Design Modeler. Now I have this Word document on the side here instead of a script. It's just what we're going to do. And I'm going back to my old format for this video. I will be walking you through and narrating as I do this. So some problems may occur with a video like this, or a setup as complicated as what we're going to be doing. So after we've imported the geometry, we are going to align it with the XY plane. To do that, we'll have to create a plane at the back of the rocket. We'll select from face. For the base face, we will select the back end of the rocket there. We'll hit F5 to generate. Now we'll create a body transformation, specifically a move. The source plane will be plane 4. The destination plane will be the XY plane. And for the bodies, we will go to the box select tool, drag a box and select everything. Click apply. Hit F5 to generate that move operation. Now that you've generated the move operation, we're going to create a plane at the base of the plus Y gear for rotation. We won't need to rotate any of the others because of symmetry. So to do that, we will not suppress, but make sure you're in single select, by the way. We will hide this face. So to do that, select the face, right click, and then say hide face. We will then create a rotate operation, but we're not going to actually rotate it because I will be setting this up with the fin in this orientation. It's already been tilted about 5 degrees. So to do that, to create that rotate operation, we will need to create a new plane about which to rotate. Instead of from plane, we will select from face. For the base face, select this face. Click apply. Generate. And for the rotation, we will be rotating the fin, the rivets, and the fin shaft. So let's create the rotate operation, but we'll leave it at 0 degrees. I'm putting it in there for convenience, so once you set this up and run it, you can go back and change the rotate option in the geometry. So instead of selecting that body, or the body tube, just go to the body selector, click on the fin and drag just over the fin, that area, the fin shaft, and the 2 rivets. Click apply. Now it's 4 bodies. The axis selection will be the plane you just created, and we'll say 0 degrees. We'll generate that rotate option just for convenience. We'll go back to a zoomed out view. We'll right click, show all faces. Now the next thing to do will be to suppress any extraneous bodies such as the cotter pins and the gears. We only needed the gear for creating that plane about which to rotate the fin. So go to the body drop down menu. As you can see, we have 30 bodies. We're going to control select the cotter pins and the gears and suppress them. Once you have them selected, right click and click suppress body. Now you'll see the green check marks have changed to blue X's, indicating that a body is suppressed. Now we'll want to clean up the cavities that we've just created in here by doing that, and this weird faces at the back. So to do that, we're going to re-extrude the body tube. Now to re-extrude the body tube, we are going to create a sketch in the XY plane. So select the XY plane, create a sketch. Under sketching, create a circle. Now we're going to dimension this to be the same radius as that circle there. If you want to find out the radius, you can select that face, you'll get the surface area, and you can use A equals pi r squared, solve for r. I use 12 significant digits so that we get more than enough accuracy, because ANSYS will only use 6 of those digits. Go to radius and type in 0.078600741606 for the radius. Hit enter. As you can see, it does 0.078601. Now that that sketch has been defined, we can extrude it. It's going in the wrong direction, but let's click apply, make sure it's sketch 1 direction, we'll say reversed. Instead of specifying a distance for the extent type, we will do to surface. Our target face will be that face. Notice how I used the selection plane to select the face that was under the face that I selected originally. We'll click apply for that target face, and we will leave it as that material, and we will extrude. Now we will unite the solid and the body tube just to make sure, or just to get rid of any extraneous bodies that are inside each other. So to do that, we'll go to create Boolean. By default, it goes to unite. The tool bodies, we will control select the body tube and the solid we just created. There we go. Gotta make sure I'm still recording. Good. And we'll generate that. We'll select the Boolean, then we'll generate. There we go. As you can see, the weird faces at the bottom of the rocket have been removed, and we just have the fin shafts. There's no empty space there anymore. Okay, next step is to add a fluid region around the rocket. So to do that, we'll make another sketch on the XY plane. We will actually be adding, oh, there's the sketch button. We will be adding 2 fluid regions, a smaller one which we can mesh more finely, or mesh with more detail, and a larger one which we can mesh with less detail. But we can still capture some flow phenomena that are happening outside of the rocket. Okay, the radius of this fluid region will be 0.25. And we will extrude it in both directions. So to do that, click extrude, apply, add material is okay. No, it's not. Add frozen. We will choose both asymmetric. The depth in this direction, FD1, will be 1 meter. The depth in that direction will be 4.5 meters, as I've specified on the Word document. We'll generate that extrude. Now, if I selected add material instead of add frozen, it would just add, it would include the rocket body in that, and that's not what we want. We want to the rocket body separately. We will actually be deleting the rocket body from the fluid region and just leaving the faces there as a boundary. And that's what we're doing next. So to do that, create Boolean. Instead of unite, we're going to go to subtract. The target body is the body you want to subtract from. That will be extrude to. Don't click the extrude feature, click the solid that you just created. The tool bodies are the bodies that you want to subtract from the so we will control select all of those. Now I must have left the solid selected, so we're just gonna choose that solid again. There we go. Now we're going to try to generate this. So click the Boolean, hit generate, and as you can see, it has failed. Now if you show the errors, it says the operation will result from non-manifold bodies. Now during the 7 hours last Sunday that I took to make this Word document, get everything set up in the right order, and set up a simulation myself, I determined that the problematic geometry is the rivets. So we're going to suppress the rivets and regenerate the Boolean. I must be still in the Boolean. So after you're out of everything else, suppress the rivets. Just give me a second here. Going to suppress the Boolean, then try to suppress the rivets. There we go, suppress body. Okay, then we will edit the selection. The tool body is the same. Actually, it's better to start over with that Boolean. Going to create it. Target body, we will select the solid. The tool bodies will be everything else. Make sure to control click that solid. There we go, 14 bodies this time. We'll generate that Boolean, and as you can see, we have one unsuppressed body with 99 faces and 245 edges. That's all from the geometry, rocket geometry. Now that we have that fluid region, we're going to make another one that we can mesh more leniently, while still being able to see some fluid flow phenomena. To do that, we're going to create another sketch in the XY plane. For this one, we will draw 2 circles. Now notice that I have drawn this circle and clicked exactly on that line, so I won't need to dimension that one. Just need to dimension the outer one, which will be 1 meter in radius. So once that's done, we'll extrude, click apply. Add material will be okay this time because our sketch is separate from any other bodies. Now instead of direction normal, we're going to do both asymmetric, say 1.0 for FD1 and the same 4.5 for FD2. We're going to generate that. And notice we have 2 solids. Now, just for consistency, I'm going to change that extrude to add frozen. Alright, next task will be to slice this geometry so we can mesh it more effectively. Now we're going to slice by 2 diagonal planes, and we're going to slice 5 times so we can get better mesh regions around the canards, the fins, and the nose. So I'm going to look at the +C direction. Now to slice by these planes, we're going to create, well, first of all, create the planes, then slice by them. So let's create a new plane. Instead of from plane, select from coordinates. It doesn't matter which point we specify for the point, but the normal vectors are what we care about. Go 1, 1, 0. Now notice our plane is perfectly diagonal, so we will generate it. And we're going to create another plane, but this time do -1, 1, 0. There we go. Now you can see plane 7 and plane 6 are diagonal. Whoops, we need to edit plane 7 because I've said -1, -1, 0. There we go. Accidentally hit F6 and that just shows the wireframe. So as you can see, now we have 2 planes. The next step is to slice the geometry 5 times. So first we're going to slice by the, whoops, I missed a step. Going to slice by those 2 planes, so select the plane, hit slice, it defaults to slice by plane because you selected a plane before hitting slice, then hit F5 to generate that. We're also going to slice by plane 7. Next we're going to slice by the XY plane. Next step is we're going to create some planes at the forward end of the regular fins, the aft end of the canards, the forward end of the canards, and the forward end of the nose, so we can slice that geometry appropriately. The idea is that we want a small mesh region or fluid region near the fins, which we can mesh with great detail. So now we're going to create a new plane. We will still say from plane, but we're also going to transform it by offsetting in the Z direction. Now note that this is the negative Z direction, so we will need to type in negative 0.4, 0.4 negative Z. And as you can see, the plane is moved ahead of the canards. We'll generate that plane. Next we will slice by that plane. The base plane is plane 8. We'll generate that. Next we're going to create another plane. This plane will be offset Z. Because you just did something with plane 8, it'll say plane 8, but go to the XY plane instead. Now for the value, type in negative 2.6875. That's at the back end of the canards. We'll generate that plane. We will slice by that plane. Now the forward end of the canards will be our next slice. Excuse me. Transform 1, go to offset Z, negative 2.8. As you can see, that's ahead of the canards. We'll generate the plane and slice by that plane. Now the forward end of the nose is our next slice. So instead of plane 10, click XY, transform 1, offset Z, and we're going to have to interpolate on this one because I haven't specified it in the Word document. So let's try negative 4 meters. That's a little too far. So we're going to go negative 3.8. Yeah, negative 3.8 should work. We just want some fluid region before the nose in this mesh area. We'll generate that plane. We'll slice. Now we will. Now as you can see, we have a fully sliced geometry, but because of symmetry, we'll only want to keep one of these, and that's this one. So we're going to select all of the other parts of the fluid region and suppress them. That's the word. So do that, select the body select tool, click and drag over all the other fluid regions, suppress. We're also going to suppress the inner fluid region. There we go, suppress. We're going to suppress. Make sure the only thing left is in the +Y direction. And there we go. There's our geometry. The last thing that we might want to do is create a name selection of the actual surface of the rocket. So to do that, we first have to select all the faces that will be the surface of the rocket. We're going to hide these faces, and we will try to zoom in a little bit. Actually, it will be useful to suppress the vertical faces as well, so I'm going to do that. Now when selecting faces, you can just click and drag, like I'm doing here. And we can hide those. Now our name selection will just be what's left here, the entirety of rocket body. So go to Tools, Name Selection, the geometry. We already have faces selected, so just drag over everything. Now we'll hold Control and then keep dragging. Actually, you don't need to hold, just click and then, or hold Control, then click, then drag. What I meant is press Control, then click, then drag. And you can release Control. Now these faces haven't been selected, so we're going to select them. Now we should have 17 faces. So we're going to leave that there. Generate the name selection. Actually, something I want to try here is doing the body select. First, I'm going to suppress these faces, or hide them. Try box select. 29 faces. Okay, that's better. This is what you'll want to do from now on. Do the box select instead of Control, click dragging. Alright, so we're going to generate that name selection. I don't know why you need to generate just a selection of faces. It seems kind of ridiculous to me. Now that all the bodies are shown, we should be good to go with the geometry. Hang on, did I suppress the I did. Oh no. So I'm just going to redo the suppression. So once again, I'm going to go back to single select, have the body tool selected, or body select button selected. I'm going to suppress all of that. That's suppressed. Last thing is this. Suppress. Suppress. And suppress. And suppress that one. Alright, there we go. That is our geometry. Make sure to have the name selection. You're going to need that when you get to solution. Okay, now that's done with geometry. So we're going to X out a design modeler and go to meshing. Now meshing will be somewhat straightforward. The mesh might refuse to generate on a few bodies. you might have difficulty with rotation. Uh-oh. Okay, we need to go back to geometry and suppress those gears too, because when you unsuppress all bodies, the the gears and other stuff got unsuppressed as well. So we're gonna suppress the rivets, cotter pins, and small gears. So we're gonna control select all those, then suppress. Yeah. So let's do that. Okay, now that those are suppressed, we can go back to geometry, go back to mesh now. Instead of rereading the upstream data, I'm going to hopefully reset now. I must have clicked on it to launch it. We're going to reset to delete all of the data. Then we're going to go to meshing. Hopefully it will reattach to normal. There we go. Check my video time here. Almost half an hour. Okay. That was better than my first take. Geometry took like 40 minutes. We're not going to bother with trying to generate the default mesh. It's going to be way too coarse for our needs. So let's jump right into things and make sure single select is selected. Click on mesh. And once you've clicked on mesh, the insert will pop up just whenever you right click. So the first thing we'll do is a body sizing. Correction, a face sizing. I'm going to select all of these faces. Let me see. Yep, I'm in the plus X direction. That's good. Now for the element size, we will do 0.0075. We don't need to generate after each of these sizings because it's going to take way too long. So instead we're going to specify everything else. So next thing is body sizings and inflation layers on the main fin region, canard fin region, and nose, and just an inflation layer on the main body. So we're going to get started with that body sizing. Sizing, once again, I don't know why it zoomed me to some weird place. It likes to do that occasionally. We're going to control select this body, this body, and this body. Whoops, I'm not even in the sizing. Okay, so now we're going to do that. 3 bodies are selected. For element size, we're going to type 5, E -3, not 4, -3. So 0.005 meters. Next we're going to do the inflation layer, which will be somewhat time consuming relative to everything else. So let's hide those bodies first of all. Next we will be hiding these faces. Next we'll go to insert, inflation. You know, I'm going to try something new. I'm going to try choosing these bodies for the geometry. And for the boundary, trying the name selection. It won't let me do that. So instead of using that name selection for our boundary, we're going to we're going to, what I did before was control click and drag over all of the faces, but instead I think I might hide the rest of the faces. So I'm going to try that. Control clicking and dragging to select the faces that I want. See if we can't hide those faces. We might have to hide these faces twice. Yeah. Alright, and then let's do a box select. Now the blue stuff shows again because that's the body, but don't worry, those faces are suppressed. Going to go to box select, select all of the faces. Should be 29 faces. It's the same as the name selection. That's good. That means it isn't including any of the faces that we hid. 15 inflation layers will work. There's what I've specified. Now we'll go back to the mesh. We're going to show all bodies, show hidden faces, and now we're going to do sweep methods on all of the sweepable geometry. Just making sure that's inflation's applied to that. Okay, now let's do the sweep methods. So insert method, geometry. I'm going to try doing one sweep method for all of the sweepable geometry. Once again, I'm in box select, and you go back to single before I can do this. This is the geometry you want to select. Click apply. Automatic, instead of automatic, use sweep. Yes, this is why I couldn't do one sweep method. So instead of doing all bodies, we'll just do one body. We'll do manual source and target. Click apply for that face. Make sure it's the +X face. And your target is the face on the other side. Your divisions is 100. So what this does, we'll sweep the face mesh through that body for 100 divisions to this face. And we're going to need to do that for all of the geometry, except for the body sizings. So going to go to sweep, manual source and target, source, click this face, target, click the other face. Number of divisions, do 100. And once again, we're going to insert another sweep method. Click apply, sweep, manual source and target. Click apply there, click apply there, 100. Tell you what, we're going to try speed this up by duplicating. We will keep duplicating. So what it does is make an identical method with the exact same selections. So what you just need to do is change the geometry, the face, or the source face and the target face. It keeps the divisions. So we're going to select this one this time, manual source and target, one face, select that face, select the other face, divisions is the same. Let's duplicate once again. For the geometry, we'll select this final body. Actually, it's not the final body, this one will be the final body. For the source face, select that face, target face, select that face. Duplicate one last time. Make sure we're in sweep method 8. We'll go to this body, this face, and that face. Number of divisions, 100. Good. Now let's check to make sure that all of our specifications are met, face sizing 0.0075, body sizing 0.005 on those on those bodies. Inflation 29 faces through 4 bodies for 15 layers. You can leave the growth rate alone. Sweep method. Just note this navy purplish color is the body. The red face is the source face. The cyan face is the target face. Just want to make sure that the source and target faces are on the body actually being swept. Otherwise, we'll get errors. That's good. That one's good. This one's good. This one's good. This one's good. And that one's good. Just make sure. Yep, there we go. Now we can try generating this. If you're doing this at one of our meetings and this fails to generate, I will help you troubleshoot. But this should work. Since it's not my computer doing the meshing, the mesh. So we'll let this run through. Should give us somewhere around 10 million nodes, which will be very nice. If we can't run 10 million nodes, there are instructions to reduce the amount of nodes so that you can get them below 512K and you can. Now we'll wait for this to complete. Next step will be setup. This is we'll try to start off with a transient simulation, but if things go sideways and we can't do 10 million nodes, we might have to do steady state. There are other assumptions that we can make to simplify the solution process. There we go. We have our solution, or not solution, mesh. As you can see, we have 9,242,834 nodes. I think that's the result of having specified the inflation over these 4 bodies. So instead of, you know what, this will work. May want to refine some other things, especially the what really matters is that when you go to one fluid region to another, that the nodes somewhat line up. If we see anything weird happening in the results at this domain, we'll know that it's a result of the mesh. But at 10 million nodes, that's unlikely. Anyway, this is your mesh. We are now done with that step. So exit out of the mesh. And especially because I've already spent 38 minutes on this, a good idea is to save this simulation. If this freezes, that means it's taken a long time to write the mesh to a database file. When I originally tried this, the mesh file was about 1 gigabyte. Or make sure you have room wherever you're going to save the simulation. It shouldn't be much of a problem if you have enough room to run the program. And most computers have definitely have enough RAM for this type of So after mesh is there, let's right-click setup. Let's do edit. If setup launches and there's no domain that shows up, then we'll know that the mesh hasn't been loaded into setup. Yeah, no domains have been defined. So let's close out of this. Go to mesh, right click and say update. And once setup turns to a little green circular arrow. Takes a while to update, especially when you have 923. So while that's happening, we're going to be doing a supersonic simulation at whatever speed we might need to. So we're going to do all of the setup except for things that we might change from simulation to simulation. So speed, we didn't change the rotation and the geometry. So you can go back and actually this would be the ideal time to do that. Then go back to mesh and update. Let's launch CFX pre. Our domain should be loaded this time because we have the circular arrow. Taking a while to load the domain because it's probably a gigabyte in size. So these are the basic things that you want to do for a supersonic simulation. Transient analysis will be nice, just because of turbulence. If turbulence diverges massively, especially when you're doing 512,000 nodes instead of 10 million. So let's say if you follow these instructions to reduce your mesh to 512,000 nodes, and let's say your turbulence residuals diverge like really badly, you might want to, instead of using the SSG Reynolds stress turbulence model, switch to laminar and initialize the turbulence to laminar as well. Wow, this is taking a while. Well, I guess I'll keep talking. There are some unique things in solver control that we need to change, like interpolation, residual target. We're going to want to reduce that. We're going to need coefficient loops because this is transient. Because air has variable properties, especially at supersonic speeds, we're going to need ideal gas model. Total energy fluid model. We don't want to neglect the fluid as it goes through the domain. That's about it. The rest is just boundary conditions. So this is taking a while. I'm going to pause the video and wait till this loads. Alright, now we have setup loaded. We're going to start specifying everything on this list. So we'll start at the top with analysis type. Leave multi-field coupling alone. We're going to go to transient. Total time 2 seconds. Time steps 0.007. Not James Bond. Anyway, initial time will be 0. Now we just have warnings there. Those are fine. So under domain basic settings, we will be using air ideal gas, continuous fluid, reference pressure 1 atmosphere, no buoyancy, stationary domain, no mesh deformation. Click apply, go to fluid models, go to total energy, SSG Reynolds stress, wall functions scalable, initialization, let's 0, 0. What I'm going to say 0, but you put whatever speed you're simulating at in there. Static pressure, relative pressure will be 0. Temperature, let's do 20 degrees Celsius. And turbulence, low intensity. You can hit apply there. Now that your domain's initialized, we can start specifying boundary conditions. No. Before that, let's do solver control. Upwind advection scheme, first order backward Euler. Turbulence numerics, first order. Coefficient loops, try 4. That's something you can change if you don't converge. Timescale control, coefficient loops, residuals, let's go 1e negative 8. Conservation target, 1e negative 6. Click apply. We don't mess with equation class settings. Now for advanced options, do interpolation scheme, pressure interpolation type, trilinear. Velocity interpolation type, trilinear. Compressibility control with high-speed numerics. Hit apply. Now we can do boundary conditions. So go to this button, boundary, type an inlet. It recognizes that you typed in inlet, so for location, type in, or don't type, go to this face and this face. You can't click and drag and set up, so you have to control click. Now it takes a while if you have 9.2 million nodes, so as soon as you click a face it might take a second or two. Under boundary details we now have the supersonic option. We will do Cartesian velocity and pressure. Relative static pressure will be 0 pascals. U will be 0. V will be 0. W will be whatever speed you need it to be. It might spit out an error if I put in 0, so I'm just going to do... Actually, this will be positive, because that's the positive Z. Let's try 400 meters a second. 0 gradient means there's no turbulence. Now for static temperature, go to Celsius. We want this the same temperature, 20 degrees. Sources, we don't care. Plot options, we don't care. And now we're good for the inlet. Next thing is the let's do openings next. So let's opening. Let's put this opening at the back. Now I could specify this as an outlet, but that would mean the speed of the or speed and direction of the fluid would have to be specified, and the speed might not always be the same, so instead we're going to use an entrainment for the opening. Flow regime, subsonic's the only option, so we'll go with that. If this messes up our solution, we'll have to change this to an outlet. That will still be supersonic. 0 pascals for the pressure, 0 gradient. Opening temperature, we'll go static temperature, and 20 degrees Celsius. Now something to note is that the turbulence and heat transfer option and the relative pressure are only for fluid that's coming back in to the domain via this opening. Fluid coming out will be at whatever pressure, temperature, and turbulence that it likes. So click apply. There's our back end of the fluid region. Click OK. We still have another opening to define. It's the top. So we're going to do another opening. I'm going to call this opening 2. It recognizes it as an opening because opening plus a number is opening, I guess. So in the location box, we'll click the top. Those are the faces that we want to specify. Once again, this will be an entrainment, 0 pascals. We'll select 0 gradient and static temperature 20 degrees Celsius for the fluid coming in. Now those arrows can get a little bit distracting, so we can unclick the we'll uncheck those boxes. Next, boundaries are symmetry. So symmetry means everything that's happening on one side of the face will get mirrored to the other side of the face. So the locations that we'll want to specify are this one side, those are the faces you will want to select, nothing on the bottom or on the left side, and click apply. Now we'll specify another symmetry object for the other side. We're going to call this Symmetry 2. Now for location, we're going to select all the faces on the other side. Okay, I see a little bit of a problem with the mesh here. This should be the face sizing should be hard, not soft. Notice how there are very few elements there. So that's something you'd have to go back and change. But you should know how to do it from what I've shown you already. Now click apply for that. And now we're done with setup. That should be it for this video. In the future, I might make one on how to interpret the results, or I might just go over that at a sim meeting. If there are any substantial errors with this video that I catch later on, I might update it or make a new video. But for now, I will see you later. Bye.